Section 1.1. Today we're going to start chapter 1. We're going to be taking a look at problem solving. We won't finish this section. We're just going to start for the first 8 or so minutes. So there is a general 4-step method that's included in most textbooks and things when you talk about problem solving. This is our book's version of that 4-step method. It was introduced by a gentleman named Polya. He's credited with it anyway. And these are 4 broad steps. When you do most of your problems, I'm not looking for you to call this step 1, step 2, step 3. It's not like that. But this is supposed to guide your thinking when you solve problems. Okay? So to start with, we're going to look at understanding the problem. And so these are some of the things that you should be thinking about when you look at a problem. Can the problem be stated differently? What is it that needs to be found? What are the things that I don't know? What information can I obtain from the problem? What information is either missing or not needed? In real life, there's usually information that you have that you don't need. It's just not necessary to making a decision, right? There's all these things, but half of them just don't apply to the circumstance. Now, in textbook problems, that doesn't always happen, but sometimes they do that, so be aware. The second thing is to devise a plan. What am I going to do? How am I going to solve this? So these are a list of different kinds of strategies. It's non-exhaustive. That means it doesn't include every possible thing. But they are things that often can help us when we're solving a problem. So you can look for a pattern. Is there a pattern going on here? Examine related problems. You've done related problems before. That's what happens when you go back in the book and you're like, oh, look, it looks like example number 3, right? It's a similar problem. Examine a simpler or a special case. Sometimes when we chunk it down from something big into something small, we can see how to do the small thing, and then we can generalize on how we can do the bigger thing. That's sometimes a good strategy. Making tables or lists. How many of you are list makers? Me too. Do any of you write things on the to-do list that you've already done just so you can mark them off? Me too. Yeah, I like making lists. They help me keep me organized. I tend to forget things less. Lists can help us in mathematics as well, either in collecting the information in a way that's sort of visually able to see what to do next, or crossing off details that are useful or not useful. And sometimes it's easier to look at a list to find patterns. So we merge a couple of these different strategies together. Identifying a subgoal. Sometimes we can say, well, if I could just get to here, then I can finish the problem. Okay, great. That means I don't have to do as much. I know half of what I need to do. I just got to figure out how to get to here, right? Identifying a subgoal. Diagrams. Do you have any artists in the room? Do any of you like to draw? Nobody? Okay, well, I don't draw well. But sometimes a diagram can still help me to visualize what's going on. And I am a very visual learner. I learn by seeing. My daughter, who's in theater, she learns by hearing. She can literally hear something and memorize it. Like I can't do that. I don't learn that way. I learn by seeing. And so visuals are really helpful for me. So diagrams are often a helpful way for me to try and figure out what's going on, even if I don't draw well. Guess and check is a valid way to do something. Did you know? Now, randomly guessing and checking is often not very, time helpful. But guessing and checking can be used, and we will see an example in this set about how we can effectively use guess and check. Working backwards. I would almost guarantee that everybody's done this before too. This is what it looks like, at least in high school. You look at the problem and you're like, I have no idea what to do. And you flip to the back of the book and you go, oh, the answer is 52. How'd they get 52? And you try to figure out how to work backwards to get that, right? We're not going to utilize it in quite that way, but there are problems where working backwards in the scenario is actually a really good method to try and figure out how something came about. Writing an equation, you'll notice, is the last thing listed on here. There is nothing wrong with equations. That's fine. If you see an equation and want to use it in a problem, go for it. But I will tell you that our goal in this class is not to try and figure out what equation can be used to solve it. And the primary reason for that is because the focus of this class is on teaching it to elementary grades, up to about grades 4, maybe 5, when we get to the very end of this particular semester. We aren't doing equations for the most part by then, at least not in the way that you thought about it in algebra in high school. So if you think about it and you want to do it with an equation, that's fine, but understand every problem that we're going to encounter can be done in some other way too. They don't have to have equations, okay? All right, so All right, once we've decided on what plan we're going to do, we're going to carry the plan out, right? We're going to work through it. We're going to figure out how to utilize that information. It talks about attending to the language that's used, checking the steps along the way, making sure that we added something together, right? It says either intuitively or formally. So formally means like actually like checking the exact arithmetic. Intuitively means asking yourself, does that make sense? Am I getting something that seems reasonable? That's intuitive, right? And then keeping an accurate record of work. This is really important. My 10th graders don't think this is important. And then when they get the problem wrong, they get really mad because what do they have to do? Start completely over. And if they'd just written the stuff down, we could probably go back and find that they missed a negative sign or something like that and fix it really quick, right? Keep a record of what you're doing so that if there are errors, you can go back and figure what they are. And I can see what they are from a grading standpoint as well, and we can fix it faster. And then the last step is to check your work. So checking your work again means two things that I already mentioned. Deciding if the answer makes sense, right? Did you get 57.39 dogs? That's a problem. There's no 0.39 of dog, right? That doesn't make sense. So either there was a direction you're supposed to round maybe at the end, or maybe you just did some sort of arithmetic wrong in the middle, right? Does it make sense? Did you get negative amount of calories for your day? Well, probably not, right? That doesn't make sense. So there's an intuitiveness, but then there's also accuracy in terms of like actual arithmetic, checking to make sure that the arithmetic matches out. And a lot of times the checking at the end means going back to the original problem and saying, does it make sense in the question that was asked? Not necessarily in all the steps along the way, but if I go back to the question that was asked, is this going to be a reasonable answer? We will pick up with the next part of this on Friday.